Welcome to today's math lesson on converting from scientific notation to standard notation. Our do now reads, which term for set A makes this diagram true? A is whole numbers, B is rational numbers, C is integers, and D is none. We are going to eliminate the answers that it is not to find our correct answer. So in terms of understanding sets and subsets and classifications of real numbers, we know that real numbers include both irrational numbers and rational numbers, but rational numbers are not included within irrational numbers. So we're going to cross out rational numbers. Whole numbers are a type of rational number, so it can't be an irrational number, so it's not whole numbers. Integers are a type of rational number, which is not an irrational number. So the correct answer is D, none. So really, the Venn diagram drawn correctly should have looked like this, with this biggest circle representing real. Then we have a circle for rational, and then another circle for irrational. And then of course, within rational numbers, there's integers and whole numbers. Today's TEK is 8.2c. Our lesson target is scholars will convert between standard decimal notation and scientific notation. We also call it standard form and scientific notation. Our DOL is given 4 problems. Scholars will convert between scientific notation and standard decimal notation with 100% accuracy. As a review of vocabulary, scientific notation is made up of a coefficient, a base, and an exponent. And the exponent can be both positive and negative. If it's negative, our number is going to be smaller than 1, so it's going to be a very small number sometimes. And if our exponent is positive, it's going to be a number larger than 1, with it being very large sometimes. And standard notation is the form or the decimal form once you multiply out the scientific notation. If you were given the weight of a whale in pounds as 2 times 10 to the power 5, how many pounds do you think that is? So first we'd have to locate the decimal in the number 2. So even though there isn't a visible decimal, we know that every whole number has a decimal to the right of it. So 2.0, the decimal is to the right of the 2, and we have to determine the number of places the decimal moves from the exponent. So in this case, our exponent is 5. So we are moving our decimal point from here 1, 2, 3, 4, 5 times. So that means that the weight in standard form or decimal form is 200,000. And what is the relationship between the exponent and the number of zeros in standard decimal notation? Well, as you can see, our exponent is 5, and we have 5 zeros here when our coefficient is a whole number. When our coefficient is a decimal, this rule doesn't always work. There's a quick Kahoot-like activity on Nearpod. Then this first I do problem. It says the mass of one roosting colony of monarch butterflies in Mexico was estimated at 5 times 10 to the power of 6 grams. Write this mass in standard notation. So first off, we have to identify where the decimal is in the coefficient. So instead of having it as just 5, we're going to write it as 5.0. And then we have to identify our exponent, which in this case is 6. So we know that we're moving our decimal point 6 places. And because it's positive, we know that we're moving it to the right. So starting there, 1, 2, 3, 4, 5, 6. Then I'm going to place my new decimal point. In all of these spaces, I'm going to put a 0. And then I have to remind myself that starting from the right, every 3 numbers has to be separated by a comma. So we have 1 comma, and then our second comma. So that means that 5 times 10 to the power of 6 in standard form is 5 million. For this we do problem, we have Diana calculated that she spent about 5.4 times 10 to the power 4 seconds doing her math homework during October. Write this time in standard notation. So in this case, our coefficient is not a whole number. We have a decimal. We have 5.4, and our exponent is 4, and it's positive, so we know that we're moving our decimal point 4 places to the right. So starting from right here, we're moving it 1, 2, 3, 4. We're going to write our new decimal point, and in all of these spaces, we're going to write zeros. So starting from the right, every 3 numbers has to be separated by a comma. So that means that 5.4 times 10 to the power 4, written in standard form, is 54,000. This next I do problem reads, platelets are one component of human blood. A typical platelet has a diameter of approximately 2.33 times 10 to the power of negative 6 meter. Write 2.33 times 10 to the power of negative 6 in standard notation. So our coefficient is 2.33, or 2 and 33 hundredths. And according to our exponent, which is negative 6, we are not moving our decimal point to the right, we're moving it to the left. So our number is getting smaller, and we're moving it 6 places to the left. So starting from here, 1, 2, 3, 4, 5, 6. We put our decimal point in the new spot, and in all these empty spaces, we're going to add zeros. So 2.33 times 10 to the power of negative 6 in standard form is 0.00000233. This we do problem reads, the weight of an ant is about 1.7 times 10 to the power of negative 5 pounds. Write 1.7 times 10 to the power of negative 5 in standard notation. So our coefficient is 1.7, and our exponent is negative 5. So that means that we are moving our decimal point to the left, and we're moving it 5 places to the left. 1, 2, 3, 4, 5. We put our new decimal point right there. In all these empty spaces, we're putting zeros. So that means that 1.7 times 10 to the power of negative 5 in standard form is 0.000017. Now we're moving on to your you-do. So it's actually going to be another time to climb or Kahoot-like activity where you're answering 3 questions. Our next problem is a small organism has a length of 7.5 times 10 to the power of negative 6 meters. Write the new length in standard notation, and this is a draw activity. Our next problem is an E. coli bacterium has a diameter of about 5 times 10 to the power of negative 7 meters. Write this measurement as a decimal in standard notation. And lastly, your DOL is a Google form. Thank you for following along and paying attention in today's math lesson, and see you in the next one.